Come on. Hello. Hello, everyone. Yes. You know the drill. Mic check, audio check, 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 1, 2, video. How we doing? Who's there? T. Hello. Anyone? Need someone to chime in? Yeah, we're streaming. Hey, Tousy House. Okay, we're good. You're good. We get Luby, first time chatter. Welcome. Loopsy Daisy. Hello, hello. Yes, welcome. Yes, episode 7. We're 7 episodes in, season number 11. Hello, my name is Ming Chow, teaching professor at Tufts University. This is Introduction to Security. Still October, so it's still National Cybersecurity Awareness Month. Yeah, today is going to be on about data breaches. How data is breached, like lots and lots and lots of data gets breached. We're talking like 100,000 millions of records. How you do that? How that happens? Hello, Magma Bandit. How are you? One thing before we begin, before we get into SQL, a good resource I want to introduce you all to is Have I Been Owned? Where owned is spelled PWNED.com. Have I been owned? Why in the world do I introduce? This is something that I introduced many people, students, professionals to this resource. My friend Troy Hunt, want to give a shout out to Troy. Maintains this still. It's a free service. It's a free service. They don't store any personal information or email address that you type in. So what have I been owned is the premise is simple. Type in an email address, your email address, to see if it's in a data breach. And you can see here on the front page is how many websites have been breached over. I've known about Have I Been Owned for years, for about a decade. 15 billion accounts. That number seems pretty conservative. There's Troy. Who uses Have I Been Owned? Cybersecurity companies, vendors, developers, law enforcement, government. Last time I checked, Troy is in Australia. But how it works is this. Enter an email address. I'm going to enter my Tufts email address because why not? Entering my Tufts email address, check, and oh no. My Tufts email address has been in 8 data breaches. What are the 8 data breaches? And it'll show you. It'll tell you the man sign. Oh, these places. A lot of. Oh, even show you the year now. This is way cool. November 2023. Scraped LinkedIn. Verification.io. You have been scraped. Lot of data brokers. A lot of data brokers got breached. Okay. Let me go to my CS account. I got LinkedIn. And another one. Let's do my personal. Yeah. Ooh. Yep, I used that for Gravatar many years ago. Bitly. Dropbox. 2012. So, look, it's not a matter of if a company or an institution gets a data breach. It's now a matter of when. These are pretty common. Have I been owned is, a really good service. It's free. It's also used in password managers as well. So you may be wondering, you see all these companies here, lots of data, like all these data breaches happen. So you may be wondering, like, how do companies get breached? Um, like, how does it happen? I mean, we're talking like millions and millions of records. And that's what we're gonna do today. Is we're gonna do a hands-on demonstration. Is that legit? Oh yeah, of course it's legit. Absolutely, absolutely is legit. Absolutely is legit. Oh yeah, I mean, if you use password managers, they usually check what have I been on. Totally legit. Oh yeah, absolutely legitimate. It's been used like it's very famous resource. Surprisingly, it's a lot of the cybersecurity stuff that like, oh my god, is this like I get it. Like, no, this has been around for a long, long time, been over like a decade. Again, I want to give a shout out to Troy. I mean, if you go to one of my favorite sites is go to Hacker News. When you go to Hacker News, and you go to Have I Been Owned, there should be a few good ones out there. Like, have I been owned? Oh yeah. Used all the time. Yeah, it's a really, really, really good resource. Check if your account has been compromised. Oh yeah. Password managers, connect to Have I Been Owned to check if your password or your account has been in a breach. But you may be wondering how it works. So, Troy and Have I Been Owned get dumps of data breaches. So, a good example is anyone ever heard of Drizzly before? Drizzly. The alcohol delivery system that you can buy. They got bought by Uber Eats, if I'm not mistaken. They got breached badly, and like 2 million records. Um, this is a story for another day, but yeah, they got breached during the pandemic. Yeah, there's an online ordering platform where you can just buy alcohol. They got breached, and so what happens is, Have I Been Owned gets a copy of the 2 million records that get breached. Uh, you know, I have all email addresses with the Drizzly dump. And so what happens is, of course, there's no point for Have I Been Owned to store any data because, well, the data breaches from like companies like Grizzly already have all that information. Oh yeah, oh yeah. So now you may be wondering like how this stuff happens. How does data get breached that easily these days? Well, a lot of it is due to really, really bad programming and an old trick. So, it due to one is due to bad programming, two, trusting user input, and three, mixing user input with actual computer code. So to understand what's going on, let's have an understanding of called the structured query language. The structured query language, or SQL, is used for all relational database systems. If you're not familiar with what a database or relational database is, think of a spreadsheet, with a lot of columns, fields, and a lot of rows. So a database, think of it as this way, is like, a glorified spreadsheet where you can hold millions and millions and millions and millions of records. That's not true for a spreadsheet because for the longest time there was a limit, like of how many rows that you can have in an Excel spreadsheet. In an Excel spreadsheet, you could like for the longest time, like it cut you off at like under 1 million rows. Now it's a little longer because it's a lot more memory. But databases, there's no limit of how much data. There's really almost no limit. There's no limit of how much data you can store. Like 2, 3, 4 million, 10 million, tens of millions of records. That's pretty common. 60 million records, that's pretty common if you're in a database. But let's do the basics. The only thing that we need to understand is the select basics. Okay? I love SQLZoo.net because it's like really interactive tutorial. So here's SQLZoo. And this has been also been around for years as well too. Interesting, I have to hit double click to submit something on a quick chat now. Weird. So here's an example. An example is, okay, you have a table, a database table called world. The world database table has 1, 2, 3, 4, 5 columns, 5 fields. Name, continent, area, population, GDP. You can infer what the data type is. We're not going to worry about data type. Okay? And you can see a sampling of all the rows, of all the countries in the world. Okay? So here's introducing the world table of countries. The example uses a where clause to show the population of France. Notice, now this is very important. Notice that strings should be in single quotes. Very important to note. Strings in the structured query language should be in single quotes. Also, the structured query language is actually is case insensitive. So you will see the general structure of a select statement in the structured query language. A select statement is the query data, is select field from table, and then followed by any conditionals. So to get data from a database table, the format is select followed by a list of the fields that you want to select from the table name. That's the most simplest format. Now, just a little keynote here. Select and from are keywords in the structured query language, and I also have them in all uppercase as well too. You don't need it to be in all uppercase, so this also works as well. This is the same thing. And why I mention this is that when you read literature or any like white papers or Stack Overflow posts, now you have LLM, they're all going to use the following convention for keywords in SQL, all caps. So by convention, I'm going to use all caps first keyword in the structured query language. So this is a general format of a structure of a select statement. So I can do, let's say, for example, modify it to show population of Germany. So if I'm going to do select population, from world. So I'm going to hit the structured query language, and it's like too many rows, wrong answer. There you go. Now, what I can also do, if you're not entirely sure of what fields you want or which fields that you want to pick, you can use a wildcard, also known as an asterisk. So select star from world. So that brings you all the records. Okay, this brings you all the records. Okay. Now you want your population. You can just do you can do multiple fields like name, population, from world. Again, too many tables, too many columns. So there's also conditionals, okay? Start with the where, okay? In this case, name equals Germany. We're going to do it right. There you go. Correct answer. So what this is from the world table, get the population of Germany. Germany, Deutschland. There you go. So this is how a select statement works. And again, notice that strings should be in single quotes. Very important. Scandinavia. You can also check a list. Checking a list, the in keyword allows us to check if an item is in a list. So the example shows the population for countries in Brazil, Russia, India, China. So show the name and population for Sweden, Norway, and Denmark. Okay, so it's like select name, population, comma population from world, where name, and of course you can change the countries. In this case, let's do Sweden, Norway, Denmark. And there you go. Okay, just the right size. Which countries are not to be used is also a between keyword. You can do this out. Okay, you can do this out. So you have a select name. What is it, between 200,000 and 300,000, 250,000. Okay. Yeah. Okay. So these are all the countries that have population, that have an area between 200,000 and 250,000 square kilometers. Between 200,000 and 250,000 square kilometers. Okay. So I think we've done enough structured query language, like select basics. I think we've got you got a pretty good primer. Okay. So, okay. But how does that have to do with, what does it have to do with anything with dumping a lot of data? Well, you know the SQL basics now, and you know that string should be in single quotes. So now let's do a real example. Let's have a table database called users. ID, username, and password. So we're going to do just plain text passwords today. Okay? So imagine that you have the following database table of users. Are we gonna play this fucking game again? There it is. Batman. You know what? I can't deal with this anymore. No. What I'm gonna do? I'm gonna use my new friend Zed. I'm gonna use my new friend Zed. Hey, buddy. Where are you? Here is my new friend Zed. I'm gonna use Fact Warrior here. Hello, Fact Warrior. What's your password? I'm going to be. Don't worry about the password. 4. We're going to say, Daisy. Okay. We can also add another record if we want. Alright, why don't we just do one more record? We got Magma Bell Bandit. Okay. So we have a database table of users here. This database table of users has 3 columns. This has 3 columns: ID number, sequential, username, password. Okay. So let's do some what they call algebra here. Let username equals user input for username. Let $ password equals user input for password, like in a form. Okay? Results equals, okay, select star from users where username equals inside single quote username and password equals $ password. Okay. We have a database table of users. We have a database table of users, have 3 columns. So now we're going to do some code here. Okay. Let $sign username equals a user input for username. Let $sign password equals a user input for the password. Okay. Result equals, select star from users where username equals single quote, $sign username, single closing single quote, and password equals inside single quote, $sign password, the user input for password. Close it with a single quote. Okay. So let's actually do a real example. So let's say $sign username. We're going to type in the user input for the username is going to be Magma Bandit. And the password that the user types in is going to be Silk Song is Hard. Okay. Let's do a plug and chug now. Replace $sign username with the user input and replace $sign password with the user with this respective user input. So now the SQL command, the SQL statement is select star from users where username equals single quote Magma Bandit, single quote closing, and password equals single quote Silk Song is Hard, single quote. First of all, is there any syntax error? No. First of all, there's no syntax error. That's good. But the next question is, okay, look at the records above. Look at that table of users above. Do we have a username that is Magma Bandit and the password is Silk Song is Hard, case sensitive? The data has to be case sensitive. The SQL command don't. And the answer is yes. Okay? Yes, there is. There is a record where the username is indeed Magma Bandit and the password is Silk Song is Hard. So what $sign result is going to be, it's going to return that record. 5, Magma Bandit, Silk Song is Hard. Okay? Hey, malware guy, been a while since you're here. In honor of malware guy. Okay? Yeah, that's your password. So hello malware underscore guy. Okay. So let's go all the way back. Oh, what did I say? Let's show Cozy Bear hello. Alright. So let's do this all over again. Do this all over again. Okay. So we already got a case. This is what we had before. There we go. Okay. So now we're at the beginning. Let $sign username equals user input for username. Let $sign password equals some username for password. Let's do another example. Let $sign username equals, well, since he's here, malware underscore guy. And the password, we're going to use a password. We're going to use Robin as a password. Plug and chug. Replace $sign username with malware underscore guy. Replace $sign password with Robin. Okay, so first of all, do we have a syntax error here in line number 16? No, we do not. Still. Yeah. However, what is the result going to be? Do we have a database record above of users where the username is malware underscore guy and the password is Robin? The answer is no. There was a record of malware underscore guy and cozy bear hello, but there's no record of malware underscore guy and password is Robin. So what $result is going to turn into is going to return nothing. Empty. So this is incorrect. Okay. But this is where things can get really wrong. Okay? So as you can see in this example here, we are mixing in code and user supplied data. Now let's go all the way back. Let's start all the way again at the beginning. Here. Oops. Now you have $username equals a username input for a user input for a username, and $password is a user input for the password. Can anyone think of where things can go horribly wrong? Remember in line number 16 the code. You are mixing in user input with actual computer code. Yes, SQL commands are code. Where can things go wrong? Here's a hint. Notice the single quotes. Remember in the SQL Zoo exercise is that strings in SQL are, covered by a single quote. Where's the problem? Let's do this example out. Let username equals our French. Okay, I'm assuming you enter a SQL command and find it. You enter a SQL command. Yeah, I'm assuming you enter a SQL command that finds a valid username password pair. Yes. Well, it gets worse than that. Malware underscore guy said high lack of sanitization here. There is no sanitization, yes, and that's a root cause of the problem. Let's do a real example out. Anyone a basketball fan here? Let username equal Shaquille, but let the password equals single quote Neil. Now let's plug and chug again. Replace $username with Shaquille. Replace $password with O'Neil. There's no sanitization. We're just going to actually plug and chug as it is. First question is this. Will this actually be a syntax error? The last couple of examples that we did, there were no syntax errors. They just worked. Here? Well, okay. No syntax error here up to where username equals single quote Shaquille single quote. We have an open single quote, closing single quote. That's fine. But what about this part? And password equals single quote single quote. That matches. Then you have Neil, and then one single quote which is left in the stray. That stray single quote is going to get a single. That's going to be a syntax error all day. And there, my friends, is where things go horribly wrong. This is going to return a syntax error. A syntax error in line number 16 in that SQL command, because there is a mismatch of single quotes. This will crash the page. The page will crash. Usually that's what happened. Or you get like a lovely email, a lovely error message, or an email too. Okay. But if this is going to fail as a syntax error, can we exploit it? Can we take advantage of it? The answer is yes. What if we did this? And this is the crux of the oldest trick in the book, better known as SQL injection. The SQL injection problem works like this. You mix user input, unsanitized user input. Yes, but wait a minute. No. You mix user input end code where you can actually use user input to return much more data than you should. Here's a thought. What happens if the username, $username, is going to be blah? You could be any. The username, the user input for username could be whatever garbage you want, whatever thing that you want. Could be anything. I'm going to use blah. But the password, however, is going to use single quotes. Let password equals a single quote space 4 space single quote 1 single quote equals single quote 1 single quote. Let's do a plug and chug now. Replace $username with blah. Replace $password with this junket right here. First question is, do we have a syntax error? Yep, we still have a syntax error because we have a mismatch of single quotes at the end. That isn't going to work. So this is going to fail. Let's go back. Let's do that now. So instead of having a closing single quote on the last 1 equals 1, we do this mess. Replace $password. Now notice how I'm highlighting $password. I remove this, paste in the user input, and there you go. All right. So, is there a syntax error now? The answer is no, there is not. Blah is properly inside single quotes, and password equals single quote a single quote. That's fine. The OR key is a keyword in SQL, and you have $1, single quote 1 single quote equals single quote 1 single quote. Okay, so if you do the math, so result equals, really what it boils down to is select star from users. Now you evaluate from left to right, where you evaluate from left to right. Username equals blah. Do we have a username equals blah? No. False. And do we have a password? Any password here that's a? No. That's false. But, or, what's 1 equals 1? 1 equals 1 is always what? True. Okay, so you have this, so it boils down to this statement. Select star from users where false and false or true. Do it out. Okay, evaluate from left to right. What's false and false? Boolean algebra. False and false is going to be always false. Okay? So now you have this junket right here, where false or true. What's anything or true? False or true, true or true is always going to be true. So really what the statement boils down to is really select star from users where true. Okay? This is actually a legitimate SQL statement too. Select star from users where true is no different than select star from users. So what's select star from users? Get all the record from user. So what result is going to be? It's going to return all the records here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, you name it. Going to dump all the records. And this, my friends, is the SQL injection problem. Mixing user input data where that is not sanitized at all. You actually mix it with a computer program, and then weird things happen. And that's how you dump a database. That's it. That is SQL injection. Now, here's the thing. This is the part that really bothers me at a global level on a day-to-day basis. When I started learning cybersecurity in 2004, The vulnerabilities that I was introduced in 2004, the biggest ones were buffer overflow, cross-site scripting, SQL injection. If you take a look at the CWE Top 25 Most Dangerous Software Weakness list, guess what's numbers 1, 2, and 3? Cross-site scripting is number 1. Buffer overflow, out-of-bound write, is number... Is it buffer overflow? Yeah, buffer overflow. Number 2, and SQL injection is number 3. So here we are 23 years later, and we're still 21 years later, over 2 decades, and we're still battling the same problems over and over again. Like no one has solved this problem. And it's still the way to dump data in database of lots and lots of records from any system. There was this really good article in 2015 on Vice. This is one of my favorite articles of all time because it's just sad. 2015, yes, I was still teaching this course, but now 10 years later, almost 10 years later, this was written in November 20th of 2015, History of SQL Injection, the hack that will never go away. And still, even up to this day, yes, I'm still teaching the security course, and guess what? SQL injection is still huge, even up to this day. One of the hackers suspected in Talk, who got hit with SQL injection? World Trade Organization, Wall Street Journal, federal agencies, all got hit with SQL injection at that time. It's the most easiest way to hack. The attack only took a few hours. But for all the simplicity and effectiveness at siphoning the digital innards of corporations, SQL injection is relatively easy to defend. So why in 2015 and also in 2024, 2025, 2023 is SQL injection leading some of the biggest data breaches around? SQL injection was actually first documented by Rainforest Puppy. Yeah, Rainforest Puppy, Jeff Forrestall. He's a great guy. Here it is that the structured query language is a programming language that used to manage databases. But Rainforest Puppy found that typing in certain commands would force a server to reveal information stored on it. People can possibly piggyback SQL commands. Okay? And over 15 years, it's still on the OWASP top 10. SQL injection is always a number one risk. This is a reflection of how many instances out there and how many factors out there. Oh, Troy Hunt, founder of the breach site HaveIBeenOwned.com, told Motherboard in an interview. Okay, so when you go to a web page and you make a request that parses parts of data and request back to the server. For example, you read a news article, and in the address bar, it has ID equals 1, and that gives you news article number 1. And then you get another one with ID equals 2. And these two lines, by the way, are really important. These two paragraphs are really important because you'll see this again and again, not only in this course, but also down the road. With a SQL injection attack, an attacker changes the ID in the address bar to something that forces the database to do something it's not meant to do, Hunt said, such as returning a piece of private data. Okay? So, yeah. So, how do you look for SQL injection attacks? How you look for SQL injection attacks is any website that actually uses a database. If you're seeing an application that uses data or returns lots of data, it's probably going to be prone to such an attack. Okay? Now, it also gives an advertisement, a plug for a piece of software here called SQL Map. SQL Map is a tool. It's free, it's open source, it crawls web pages on a website, to look for input forms on the website and submits the form with input that might cause a MySQL syntax error. There. Okay? SQL Map. Okay, SQL Map is a free and open source tool, one of my favorites on GitHub. SQLmap.org. is the this is legitimate too. SQL Map is free. It's open source. It automates the whole process of detecting and exploiting SQL injection flaws and taking over database servers. You can also use SQL Map to dump data as well. It is fucking awesome. You can view the project on GitHub. It's written in Python. Okay? It's written in Python. SQL Map is an open source that, automates this thing. So here's the deal. You can use SQL Map. I use SQL Map because there's a lot of complex SQL that I don't know of. But before you go guns a-blazing using SQL Map to test for SQL injection and dumping database and stuff, let's understand how SQLites actually practice SQL injection on a few playgrounds. Okay? Few playgrounds. So what we're going to do now is we're actually going to use, and I set something up for each and every one of you to use, called a damn vulnerable web application. The damn vulnerable web application is a free and open source web application that is, well, deliberately vulnerable. Ah, shoot. Come on. There you go. Free and open source. Now, I actually have an instance of the damn vulnerable web application open and available for people to use. I'm going to paste this URL. Hello. Oh my god. That's the URL. This is safe. Just don't take it down, please. Don't do anything stupid. Alright. The username is admin. The password is password, all in lowercase. Okay? You log in. So I'm going to reset the database here, just for the heck of it, just to clean out all the crap that we did yesterday. Here we go. Yeah. Alright, that's good. Admin. Password. That's the username and password to log in. And so the damn vulnerable web application is a tool to aid security professionals to test their skills and tools in a legal environment. Help web developers, students, teachers to learn more about a web application security in a controlled environment. Here's the thing, is that this application is damn vulnerable. Alright, it's damn vulnerable, so don't post it on a public server, which unfortunately I did, but, I have very good reasons. Okay, now? So now, we're in the damn vulnerable web application. Let's do SQL injection. Here it is. Find the vulnerability. ID equals 1. Okay. ID equals 2. Okay. ID equals 3. Okay. Find the vulnerability. And here's the hint. The hint is in the source code right here. Looks familiar? Should look very familiar. That's what we've been doing the whole time. Who was it? It was malware underscore guy. Malware guy, you were saying that there's no, the example that we did here, there's no sanitization on the user input. The same exact shit that is here. Where user ID equals single quote, $ID, single quote. Same idea, just different parameters. So instead of entering username and password is, alright, find the vulnerability. Where is it? What do you do? Dump all the data. $99. There's no 99 record. How about this one? 1. Alright, that's 1. But what if we did this? Here's a hint code that we are given. to use a single quote here. What if we did this? One single quote and hit submit and ooh, HTTP error 500. Ooh, we're onto something. Anytime you crash a page, it's a sign that there is SQL injection. Okay. All right. So a single quote will crash it, but what happens if we do an or single quote one? That works too. Here's why. I'm going to take a copy of this SQL state to check the database. Check this out. I don't need this anymore. But what did I enter in? What was my input? One single quote, space, or space, single quote one. Why does that work? There, that's why. Where user ID equals 1 or 1. Well, okay, anything or 1, okay, 1 or 1. Where user ID is a true or 1, and so that's going to be true. Okay? Yeah, that works. Another way you can do this is A or B equals, what's this one? Does this work? No, that's not going to work. Although it's legit, though. Replace $ID with this. Or B equals C. Username equals, first of all, there's no user ID equals A, because we're dealing with numbers. Or B equals C is false, so we got like false or false. That's not going to work either. What happened if we did this? $1 single quote space or space single quote B single quote equals C. You only get ID equals 1. Okay? That isn't going to work. So it's this piece right here that need to be like true. But remember, why is 1 works? Because remember, 0 is true, is false, 1 is true. Okay? So let's go all the way back. So what you would do is like a single quote or space single quote 1 single quote equals single quote 1. Hit the submit. This is always going to return true. Bring back all the records. There you go. Okay, so there's a SQL injection blind here. The same idea. Blind okay, SQL injection. What's the difference? No, most of the stuff. Blind SQL injection allows an attacker to execute malicious SQL queries in a database without directly seeing the results. So instead of receiving visible data, the attacker infers the information based on the application's behavior to read error or response times. Okay. So we just dumped this database table here when we did SQL injection. A single quote space or single space single quote 1 single quote equals single quote 1. Hit the submit button. Okay. And now, before I move on to the next example, I want to give a shout out to XKCD and the famous Bobby Tables. Bobby Tables. There's a famous, very famous XKCD called Bobby Tables. Okay, from XKCD. Hello, this is your son's school. We are having some computer problems. That's one. Oh dear, did he break something in a way? Did you really name your son Robert, single quote, close parens, semicolon, drop table students? Oh yes, oh yes, little Bobby Tables we call him. Well, we lost this year's student records. I hope you're happy. And of course, the person said, and I hope you've learned to sanitize your database inputs. I think that malware underscore guy appreciates that. Ha, there you go. So, why does SQL injection really happen? Okay, how does SQL injection, why does it happen? And first of all, you have unsanitized user data. But the other thing is you mix in code and data. By in this case, what we've did is string concatenation essentially. This is essentially string concatenation. It's no different. Okay. So how do you prevent this stuff from happening? There was this really good post on Stack Overflow. How can prepared statements protect against SQL injection attacks? There's no excuse why SQL injection should happen these days. Okay? There's absolutely no excuse. Okay, so here's the idea of SQL injection. It says the idea is very simple. The query and the data is okay. Here's what prepared statements is. Every single programming language now, Python, Ruby, C, C++, Java, they all have a prepared statements like PHP. They all have a prepared statement library. Think of prepared statements as parameter binding, separating out user input and data. The idea is very simple. The query and data are sent to the database server separately. That's all. The root of SQL injection problem is the mixing of the code and the data. In fact, our SQL query is a legitimate program. Here's an example that we did. And we are creating such a program dynamically, adding data on the fly. This is what we've been doing this whole time to produce a malicious sequence. Okay? We are adding data directly to the program body and then it becomes part of the program so the data may alter the program and depending on the data path we will actually, yada yada yada. In prepared statements, the way you resolve against SQL injection, of course number one is to validate input. You always want to do that. But is to not mix code and user input. So here is the better way. The first thing that you do is you do not alter the program. It remains intact. We are sending a program to the server first. And you notice that the parameters, in this case the variables, have a binding of a question mark, where the data is substituted by some variable called a parameter or placeholder. Fine. Note that this exact same query is sent to the server without any data to it. Then in a second request where you throw in the data, essentially separated from the query itself. So it can't alter the program and do any harm. That's it. So the best way to resolve cross-site scripting SQL injection is to sanitize user input. Okay, injection attacks always sanitize user input. But for SQL injection and for like any injection attacks, like especially with SQL injection, NoSQL injection, prompt injection for LLMs, you always want to separate out user input from the code. Never mix. Doing string concatenation, no bueno. Okay? So, this is the way to resolve SQL injection. But we're not done yet. I want to go back to the damn vulnerable web application. I want to go to an example that we might have missed. So I want to do cross-site scripting again, but this time I want to do cross-site scripting stored. Okay, so I want to enter a name, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q. Oh, wait a minute. A, B, C, D, E, F, G, H, I, J, K, L, M. Okay, that's not good. There's a character limit on the name. So if you do cross-site scripting, you can't, I have a character limit and a name field. Okay. sign the guest book, it works. But if I try to do a SQL injection attack, I can't do it. What the fuck? Even if I get in the message column, alright, maybe I can do it here. And this should work. That's a cross-site scripting. But there is a character limit on the name. Is there also a character limit on the message? Oh. Oh. Let me do an inspect element here. $50 is a max length. Okay? 50 is a max length. I also have a deliberately vulnerable voter database. If I do a search for vulnerable database, here we go. I wrote this. It's on GitHub. It's free. Anyone can have it. So I wrote this project, holy shit, 4 years ago. 4 years ago, I did this project to demonstrate what happens when a voter database, including web forms, are not well developed and have vulnerabilities. Here's your installation instructions, and then you have a vulnerable voter database. Voter databases get breached all the time with SQL injection. And here's your articles and references that support that. They're still up.
ABC 7i team is looking into Russian hackers and how...
Nice. 2005 hacking technique called SQL injection. Okay. So... yeah, this was not written by AI. This was all written by hand. There was no AI 4 years ago, really, that did this work. But this is a deliberately vulnerable voter database. Okay, so this was based off of, I almost got into hot water with this, with the Massachusetts Find My Voter Registration database. But I have an instance running here at VoterDB. There's the link. So you may be wondering, like, why? What's the relationship? So here's a fake Find My Voter Registration status system. Oop. Man, this interface is horrible. Where's my mouse? Oh, I just had it. First name. Okay. Wait a minute. All the years and zip code is what? That's it. 5 characters. And you must check this box off and you got no results. The similarity between this fake voter registration status page and this page right here character limit. There's a 5 character limit here on zip code. That's it. 5 character limit. So you may be wondering, does it make it a little bit harder to dump a database even if like these fields are all filled in? Like your options are January to December and date of birth month. You have only limited option in day, limited numbers in years. Does it mean all hope is lost? The answer is absolutely not. One thing that people fail to understand is even these fields, even if they have some security built in or character limit, like 520 character limit or like certain number of years, you can still bypass this on the client side. You can still bypass them. The way you bypass it is by using something called a proxy. A web proxy is a middleman tool. It runs on your computer and it intercepts everything that gets before the request gets sent to a server. It intercepts all the fields. Remember how the web works is request, response, request, response. So right now, when I actually if I bring up another tab, and I type this URL in, and I do my magic one finger salute, it's going to make a direct request to 3.23.79.116. And I get a response back from 3.23.79.116. So, proxy is no matter. Let's say, for example, you hit the submit button. But what if everything that you type into a form gets intercepted? Then you can make any changes that you want to the user inputs, regardless of security that's on the page. Make your changes and then send those to the server. And that's what a web proxy software does. Again, right now, if we hit the submit button, we do an incomplete. You hit the submit button right now, it's going to do a direct request to 3.23.79.116. Web service proxy software, they're all over the place, but there's a few really good ones, a really few famous ones. One of them is called Burp Suite. Burp Suite. Burp Suite is proprietary. Burp Suite's been around for a very, very long time. It's built by a company called Portswigger, and is used by cybersecurity professionals. Portswigger.net/burp. Okay? They also have a web security academy, so you'll find more exercises on like SQL injection, cross-site scripting. You get LLM attacks, XSE, SQL injection, 16 labs. There's a whole bunch of SQL injection labs here. Want to give a shout out to folks up Portswigger? They've done this for years. Burp Suite's been around for a very, very long time. Very long time. But their most famous product is Burp Suite. There's a professional version and a community edition. The professionals swear by it, but that's not what we're going to use. We're going to use the community edition. The community edition, what it has is a web proxy and a web browser, but it doesn't have like the automated scanners. Okay? So here is the difference between Burp Suite Community Edition and Burp Suite Professional. There's a web proxy for the Community Edition. So the Professional will have a web vulnerability scanner. Enter in a URL, hit the Enter key. Okay, so now I'm going to give you a demo. I'll show you how to use a web proxy. In this case, namely Burp. So I installed, it's platform independent. It's written in Java. This is how it looks. I'll copy this URL. Don't need this anymore. Well, welcome to Burp Suite. There you go. Hit next. Start using Burp. One of the most beautiful things about Burp is it comes with its own web browser. It comes with its own version of Chromium. So you no longer have to configure your web browser to use the web proxy. You don't need to do any of that anymore. So now there's so much to do here, but the thing we're going to use, go to the target tab, and there's no targets. We have no targets here. We have a proxy tab though. Go to proxy. You can see all the HTTP history and a lot of cool stuff. Right now, intercept is off. If you turn intercept on, messages between Burp's browser and your target servers are held here. This enables you to analyze and modify these messages before you forward them. I'm going to open up the browser. There we are. So you got Chromium. So I'm going to type in the HTTPS :/3.23.79.116/voter.db. Fill in the fields A, B, C. Hit enter. Okay. So right now it's still doing a direct shot from the browser to the server. Direct request. Now what we're going to do is we're going to turn intercept on. Intercept is now on. Now we go back and let's fill in the data field. I think it was 77 was Star Wars, yeah. Hit the enter, you need to check the box off. Now watch what happened when I hit the submit button. HTTP, post method, the URL, and now you can see the data that got intercepted. You see the entire HTTP post request. This is the entire HTTP post request. Post verb, all the key value pairs, and notice the request body. And you can check the take a look at the inspector here. You can see a drill down of all the request attributes, the request query parameters, request body parameters, request cookies if there are any, and request headers. Really cool. This is why HTTP request and response headers are really important. Because now what do you think you're going to do? You're going to mangle the data. We're going to actually modify some of these values here. In fact, the one that we're going to modify is a zip code. So I'm going to actually see if I can do this. I know I'm going to go through my head here because I'm streaming right now, but that's fine. And now I'm going to have the browser. This is one nice thing about having a nice big screen. You notice that there's a, on the tab here on the browser, it's still circling. Watch this. So there's one or two ways that I can modify. You're going to do SQL injection. We're going to do SQL injection on the zip code. One way to do is to modify the value here in the inspector, or you can even do it here. Okay. Why don't we do it right here on? You know what? We can just go to here. We can do that. So we can do a single quote space or single quote 1 equals single quote 1. No closing single quote. So that's our payload. A single quote space or space single quote 1 single quote equals single quote 1. We made our change. You see the tab on the browser is still circling. So now I'm going to hit the forward. Now we've made all of our... Oh, you know what? I should actually hit the return key. Yeah. Hit the return. Now I'm going to hit forward. Watch what happens. All the data gets dumped. All fake data. So you may be wondering, you know what? Could I just right-click on Save the HTML and modify the HTML? I see a lot of people do that. They say, yeah, they right-click on the HTML, you know, on the form, and then make changes. So I'll give you an example. So I do. A lot of people, what they could do is they do a save page as, save it to your desktop, and then modify. remove the constraints on the input fields. Yeah, that's all the data. The problem with that idea is this: you don't take it. One of the things that Burp has, you got HTTP history. You have your history here. The other thing is, if you go to Target tab, it can actually build a sitemap of your entire website or target that you're building. A good example is, let's say, for example, you go to Facebook. Go to facebook.com. Oh, did I have an intercept on? Oh, intercept. Yeah, intercept is on. But why is? Oh, wrong, wrong web browser. Facebook.com. You go to Facebook. Hit forward. Keep forwarding. Keep forwarding. Just you can see all like the underworks of how Facebook is, and then we'll just build a target of Facebook. All the yeah, you can see it breaks down and drill down Facebook. So you won't get this at all. I mean, this is one of the nice things about having like a burp suite that does that stuff for you. Because if you're going to be analyzing a website for security, you want to have a sitemap. And the proxy is you're going to do a forward, you can do a drop, you can drop stuff. The one more that I'm going to do now to show you how you can just bypass things like the cross-site scripting form field. And DVWA. Yeah, I want to do just a GET request. I want to forward that. Yeah, drop the Facebook one. Forward this. Forward. Okay. Don't need Brave anymore. Chromium. Admin. Password. Yeah, then you could see the admin and password gets, they get intercepted. Here you go. Forward that. Forward. I'm going to turn intercept off for a second, but now I'm just going to go to XX, the cross-site scripting stored. Yeah, I got a bunch of these things here, but now I'm going to turn intercept on again. Now I'm going to do like what? A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. 1, 2, 3, 4, 5, 6. Let's do that. Hit the sign guest book and notice what happens. You can see the text, the field is what? Text name. Yep. These were the input fields. So now what I'm going to do is, there was a 10-character limit on name, so I'm just going to say, hello, Barry, open script, window.location equals single. This is going to be way longer than 10 characters. Can't do 4chan because I think I'll get banned on Twitch for that stuff. Okay. Message is whatever. Okay, now I'm going to say, watch what happens. I'm going to forward the request. Now what's going to happen is, because the input field for the name is now way longer than 10 characters, I'm going to forward the request. It should just bounce you to, okay, you get the cross-site scripting. Oh, goes to Twitch. Yeah, why not? I'm going to close the interception. It gets off. Here you go. And so that, my friends, is SQL injection, and also using web proxies as well. They go together. SQL injection and web proxies go hand in hand. So now I'm back here, and so the 7th lab for this course really is, for the 7th lab of this course, just go to this 3.23.79.116, break into the website. Now you actually have, from based on today, you have all the skills to break into this website. If it takes more than 2 minutes, 3 minutes for you to do so, then you're doing something horribly wrong. So this should only take a few minutes to do, to break into the site. Everything that you've learned today, we're going to break into the site. I know I'm like going to be over time here, but I'll show you one more thing. You may be thinking, okay, if you actually use a Mongo database, you're not going to have the same problem because Mongo database is no SQL. They don't use SQL. That could not be more wrong. It could not be more wrong. You still have injection problems. You still have problems. Yeah, no SQL injection is still is a thing. In fact, I did the presentation on this many years ago. And before I go, I just have to do this. We did SQL map earlier. No SQL map. I know I don't like to bring this topic up, but I have to. Want to give a shout out to my friend Russell Batterini. No SQL map. You know, it's the same idea as SQL map. Okay, it's an enumeration and web application exploitation tool. Originally written by Russell Butler. Oh, so Russell the accountant. Oh yeah, so he's a smart one that got off of Twitter. So TCSS tools. Russell Butterini wrote NoSQL Map. Attributed to SQL Map, and its concept is based on my presentation at DEFCON 21. And of course, Russell and I and family have been friends ever since. Want to give a shout out to Russell. So, yes, the idea is even if you move to NoSQL, it doesn't do you any good. In fact, NoSQL, MongoDB is another world of hell that I don't even want to talk about. But that's good for today. All right, folks, that's all for today. Take care. Yes. Stop the screaming.